Good season of the year, everyone. Welcome to the series of virtual company tours organized by EPIC, the European Photonic Industry Consortium. And today we bring you to sunny Barcelona in Spain to visit a medium-sized enterprise, ASE Optics Europe. This company specializes in optical design and the engineering and integrated optical systems. Their design and systems are already in use in several national laboratories and widely used in research and medical centers for different applications. ASE Optics provides you with a complete service, including the design and integration of optomechanical and optoelectronic systems. They develop program-specific software for image processing, image analysis, image recognition, and image enhancement. And at the completion of the optical design, they can assist you in fabricating of their prototypes and small series. They also have experience in manufacturing and assembly of custom precision systems and equipment. Today, we're going to meet the team of ASE Optics Europe that consists of engineers and technical experts with experience and knowledge in different areas, including the scientific research, industrial applications, defense, and aerospace. And you will have a chance to ask them questions in live. So we have Lydia Briquet, the Director of Sales and Marketing at ASE Optics with us here. Hola, Lydia. What did you prepare for us today?
Hello, welcome to ASE Optics Europe. Today we will visit our facilities and we invite you to discover more about what we can do in optical design and engineering for custom integrated systems development.
Welcome everyone to ASE Optics. We're really excited to do this virtual tour. And I want to throw out a big thanks to EPIC for encouraging us and helping us to make this possible. So welcome to our site. I hope you enjoy meeting my colleagues here that will be showing you through the process of where we design and make the engineering happen, to going down and seeing where we actually build and assemble and test some of the products and components that we build for our customers. So I give it back to you, Lydia, and of course, let me know if you have any questions.
No, thank you, Andreas. I think we can go forward and see the labs.
Okay, yeah, thank you. First, we will meet now our technical office. Come on. This is the optical design area with our engineers, and let's meet Zaira, one of our optical engineers. Hello, Zaira, how are you?
Hello.
Hello, Sarah.
Hello, how are you?
What do you have for us? Very good, how are you?
Fine. Well, welcome to the Optical Design Corner. I'm Zaira Verdiñas. I'm an optical engineer here at ASE Optics, along with Paloma Matia, who couldn't join us this afternoon. Well, I will introduce you some other members of the team. They are Asma and Gregoire, who are doing their internship, here at ASE Optics with us. So, yeah, I like to think about the optical department as the first stage in which a project becomes a real product. So here we design our custom optical systems, which are made for a broad different approaches, from medical to space to even defense. So since we touch many areas and we only produce a small series of products, every design is quite unique and involves a lot of innovation and research. So we mainly work with CMAX and Code5 software packages, but not only to do the design and optimization of the systems, but also the tolerance and thermal studies, and as well as the striatal analysis. So I will show you what I'm doing right now if you want. I'm working with a project with this even more special for me because my background is in astrophysics, and this is an infrared camera that will be on board on a satellite. His aim is to monitor the Earth and unveil different events such as fires or other climate events. So what I'm doing now is to check the performance in terms of striatal. So I don't know if you have any questions about the project or the department in general.
Yes, thank you, Sarah. So yes, I would like to remind everyone participating that you have a chance to ask questions in live. Just to use the raise hand button if you have a question in mind. And yeah, Sarah, it's very curious what you're doing. And so how long is a typical project in optical design?
How long? It depends a lot. There's a few of them which are quite large, let's say 1 year or two, but most of them are done in terms of months.
Okay, thank you. We have a question from our technology expert, Tracy Vanik, please, Tracy.
Hey, this is very interesting for me, especially when you mention that you are doing developing an IR camera for a satellite system. So is this, I think you said it was going to be used for weather. Is that correct? It sounds fascinating, and I'm assuming it's an IR camera? Or you said it's an IR camera. There we go.
It is. And I think not especially for climate. We have another project, which is indeed an infrared camera for climate. And I think not this one. It's just to take image from the Earth. And it will have many different applications, not only climate.
So would this be looking at geological events or more countrywide events? What can you share any of that information with us?
Well, as I know, they will monitor different things, like for example fires, as I said. But to be honest, I don't know what else they will do with this camera.
No, but that's very interesting, especially being able to do this from a satellite perspective. Do you happen to know if it's a low Earth orbit satellite or if it's like a HAPS satellite or?
I would say low orbit, but I'm not sure, to be honest. Yeah, low orbit. Sure.
Yeah, no, this is very
told me around there. Well, actually, this is the second phase of the same project. The first camera was already launched in board of an SpaceX satellite, the launcher, I don't know how to say. And it's already working. So this is kind of an improvement of this camera.
This is excellent, and this is a very unique application, and certainly leverages your IR expertise. So interested in seeing more. Thank you so much.
Thank you. You're welcome.
Thank you. We have one more question for you from Evgen Barwald from MPS.
Yeah, hello everybody. So my name is Eugen Berwald. I'm from MPS Microsystems, and we are doing micromechanics for positioning or making some customized zoom functions or whatever. So my question would be: are you using in this project or some motorized zoom function, or in general, how often is it used in your company?
Well, not in this project, but we use this kind of systems. We have, at least as far as I know, there's one of them in the lab that we use very often.
Okay, so maybe there could be a potential for cooperation. Thank you. I will contact you or your colleagues. Yeah, thank you.
Yeah.
Thank you, Eugen. Thierry from Lambda X. Go ahead. We don't hear you. Please unmute.
Okay.
Yes.
Yes. So this is Thierry Moreau from Lambda X in Belgium. I was wondering if is it a ESA project or is it a new space application for a commercial project? Could you tell a bit about the type of projects you are designing for space?
Perfect. Yeah. Well, this is a new space project that will be in a CubeSat satellite.
Okay.
Well, I think I can say no. Okay, I can say the customer, but it's a public one. The funds are public. We have two of these type of projects already in like going on now in our company.
Thank you.
Okay. Thank you, Sarah. So Lydia, maybe we can move forward. Thank you. Yeah. Thank you for the explanations.
You're welcome.
Okay, thank you. Now we are going to the another area. It's the optomechanical design area.
Okay, great.
Yeah.
Lydia, please pass them both headphones in the ears.
Yeah, sure.
And then,
Here we have Jorge. He's the main optomechanical engineer. Jorge, both.
Hello, can you hear me?
Hello, Jorge. Yes, we hear you well.
Hello, hi. Thank you. I'm Jorge Oriol. I'm mechanical engineer here at ASE Optics. And well, what we do here is once the optical design is finished, we wrap it up everything and implement all the different components that needs the system. So what we usually do is once the optical design first version is finished, we start with the mechanical design. We start implementing all the components. We usually have a meeting with the optical designers, so they tell us how the system needs to work. If there is some kind of compensators, we talk about tolerancing, we talk about performance, so we know how to start with the design. And we develop on the system, and we usually have some intermediate chats with the optical design because sometimes we find some issues and they help us to solve by redesigning a bit the optics, and at the same time we design the mechanics so they can. It's like an iterative project, an iterative process where both teams work side by side, so we can try to solve all the issues that we met. And well, once all the mechanical design is finished, we had a critical design review where we check everything again. We check all the tolerancing, all the assembly procedures. We check that all the systems are well implemented. And if everything looks great, we can move to the production phase, where we need to do all the documentation to launch to production. We do all the components of all the drawings of the components, also both mechanical and optical components. Also, we do the assembly procedures, the assembly documentation. We do bill of materials, and also sometimes we need to talk with our suppliers so we can talk if all the parts are manufacturable and the tolerance that we are asking for are going to be reachable for them. And once we do all the documentation, with the package of the documentation, we launch it to production, and this is where we stop. This is where all the work that we've done here in this area. Do you have any questions or?
Yes. I'm very curious, actually. Where does the majority of the projects come from? Which area? Is this industrial applications? Is it defense? Is it aerospace?
Yeah, we work
have
for.
The most competence?
Yeah, we have lots of areas where we work with, and most of our projects are from investigation companies that needs to implement and at some kind of their process. They need a customized specific optical element or optical system, and this is where we can develop these custom optics that fits perfectly to their process, and then they can implement it to their process. So most of our projects came from industrial areas where they need to implement custom optics to their system. But we also work for defense projects or with medical projects, or the areas that we work from. Our projects are very, very open, but we mostly work from to industrial area and to development companies. Yeah.
Thank you. That's interesting. We actually have a representative of ANSYS, the designer of the ZMAX studio, in the room. Thomas, would you like to say a few words?
Okay.
Yes. Can you hear me?
Yes, I can hear you.
Okay, cool. So I'm Thomas. I'm the manager for the EMEA team at ZMAX ANSYS, and I'm very glad to see that you're using Optic Studio there. I hear that you're talking about thermal simulation as well as optomechanical, and I just want to share with you that we've got some products especially to do that. And if that is of interest to you, you should call us and we can demo those tools for you. We have one product which is very new with ANSYS. It's called STAR, and it brings the data from finite element analysis. And typically people, they use that with heavy thermal calculations to see the impact on the optics and the mechanical, and you can load all this data to ZMAX directly. So it can make the study of a thermal much more easy than you are doing the thermal directly in ZMAX with this new mode. And for optomechanical, I've heard that you are communicating with the optics team. So I guess that you are sharing a lot of files as step from Optic Studio to optics to Creo or to I don't know which software you are using here, maybe SolidWorks.
SolidWorks, yes.
Yeah, so this is also one aspect where we can probably help you so that optical engineers and mechanical engineers are working on the same file instead of changing. I've seen companies where people spend a lot of time trying to discuss back and forth. Oh, it's here, you need to remove this little bit. This screw is not at the right place. If it's on the same file, on the same computer, it can go much faster.
Yes, for sure.
Check it out on our website, and I'm happy to give you a call and demo this for you.
Of course. I don't know if you have our contact.
Yes,
so you can.
I'm pretty sure we do. If that's okay, I can send your details to my team.
Epic will put you in contact. No worries. Thank you, Thomas.
Thank you.
Okay.
Tracy?
Yes.
Yes. Oh, this was very interesting. All right. So I was curious when you mentioned about the physical mounting or the physical design for the product. Are you mounting the lens, or are you just doing something a little bit more detailed, such as beam steering or perhaps system design? What exactly? What aspects of mechanical design are you doing?
So, when we design the optics, that's just the optical design. We have the lenses, and here at the mechanical design, we just have the information of the lenses, and we can see in the space. So we need to design all the mounts where are the optics are going to be mounted, how are going to be mounted, and also check if the mounting process of these optics are going to be satisfactory for the optical performance. So we do all the mechanical design from zero. We just receive the optics, and we need to figure out how the mechanics can be mounted from zero. We need to design everything. So we do all the phases of the mechanical design.
That's great. Do you get involved in any dynamic beam steering or beam focusing, or are you mostly putting in the optics into a system for operation? For example, if you're using an IR viewer for the military.
We design everything, and then with the optical team, they check if there is anything that isn't working from the optical part. So if you want, you can chat with them, because I'm not really, I don't really know how do they check that all the optics are working, because it's another area. But you can send us an email, and we will send you all the information that you need.
Okay. No, this is perfect. So thank you so much. And with all of your custom work that you do, I'm sure that you are very busy. So thank you so much.
Thank you.
Yes, just one more question. Mark from Lightpath, do you have something in mind?
Okay.
Mark, you can unmute yourself. Yes, unmute.
Hello.
Can you hear me now?
Yeah.
Yes.
LightPath is the optical component manufacturer. We also do optical and mechanical design in-house, and we assembly lenses as well that we manufacture. So fully vertically integrated. The facilities are in US, China, and in Europe, also in Latvia, where we make lenses and do coating as well. Work mostly with the infrared materials, and we produce the chalcogenide glass ourselves in-house as well. I believe we had, a couple of projects that we worked together with ASE guys in the past. Okay. My question is that the mechanical design that you do, that's for mostly fixed focal length systems. So those lenses are, or they're moving?
No, we do both. We do both mechanical designs. We have some designs that they don't need compensators or anything, but we have developed some systems that need refocusing manual or also with a motor or doing some kind of some electronics. So we also do both kind of mechanical designs.
And the questions on testing of the systems, that's to you, or there would be a dedicated presentation? Someone else will talk about the metrology.
We do have some test area downstairs. You are going to see it now in a few minutes. So okay. we can do also some testing in-house. Yeah.
Thank you.
Okay. Thank you, Mark, for your question. We can proceed with Lydia.
Okay. Right. Okay. Goodbye.
Goodbye.
Okay. And now the last part of this area. Let's meet Marino. Marino is our imaging scientist expert, and he's in charge of all the non-optical and optomechanical parts. Now he will explain better what he does and what he provides to the custom systems integration and development.
Great to meet you, Marino.
Hello, nice to meet you. Well, what I do here is providing the software interface for most of the systems that we produce. And basically, this is where some more complex systems that require some software access, some smarter control, get their face to the user. We basically try to develop something based on three legs, which is one is the system that in some case can be quite complex. Another one is the operator, so that the operator can use this complex system in an easy way. And third one is the customer, because of course, perhaps the customer is not the final user of the system. And basically what I'm doing now is sort of integrating a few of the GUIs, the graphical user interfaces that we have developed for a few different projects. So basically, you can see here that our system, this is a very complicated example of a system where we have FM systems, lock-in amplifiers, a robot arm, and everything has to be controlled in both a simple way from the user, yet it has to provide all the information that is required to understand what's going on at any moment. So we have developed a software base that provides us with full of details to understand where the system has met any problem, if any arises, or if the user just wants to dig in and understand how the system is performing, then he can also dig in this information which is collected so that we have a better access to improving our products. We have this kind of approach so that the system the systems can be can provide very easy to use, can provide easy to access information, and we provide data in the most common file formats, so that this information can be accessed in a very straightforward way. For instance, apart from being accessible from our own GUIs, this information is also accessible from other more widespread formats, like a simple HTML plus SVG graphs, which is very useful because, of course, anyone can access the final data collected by our software. And we also provide a help to our customers in the field of algorithms. For instance, in this case, to a customer of ours, we have helped in improving the display of their images that were displayed in a traditional jet palette. But then the problem arose: how can we improve the visibility of this information? And so we started, even at a colorimetric level, how we could improve the information. And we came up with something that actually has much improved the information content accessible from the operator. And so it's a mixture between the what we have as a final application, and how it can be used, and what's the proper use for the whole hardware chain. So basically, that's to resume in a very simple way. And if you have questions, please come.
Thank you, Marino. I'm wondering, do you provide, let's say, a post-sale service? Do you support the clients that can use this software after the project with them is done?
Well, we try to. The software is not actually a product that, as of now, we have provided, because we usually have a very individual software produced. So basically, as of now, we are still in a phase where we develop the software in a very close collaboration with our customers. It's not meant for many copies, but we are working on this in order to have a more widespread use of these tools.
Right. Okay, but still, if once they start using it, they can always come back to you in case they have
Absolutely. I can even show you how we can access to the whole information, so you can see that at any time we have the tools already and developed in order to understand what's going on with our code. And really pinpoint where any problem arose, so that we have developed already the infrastructure to improve on this aspect of our products.
Okay, thank you, Marino. I think we can proceed with Lydia further away. This was very interesting.
Okay, thank you for your interest, Lydia.
Hello.
Oh, okay.
Hello.
Hello.
This is Luis.
Nice to meet you.
Nice to meet you. Welcome. I am a Chief Operation Officer from ASE. ASE also integrates and manufactures complete systems, and sorry.
We hear you well.
Yeah. When the design is complete, sorry. Yeah. When the design is complete here in the technical office, the work in the production area starts. Please let me know. Let me show you where we do.
Okay. Yes. So we're going to the labs, right?
Yeah. Follow, please.
Okay, great. So yes, I basically, from my understanding, and we'll see now, the ASE Optics fosters the innovation in optical systems, custom optical systems development and integration. And their facilities are prepared to offer a complete service in optical design and manufacturing. And laboratory areas with the lenses assembly and testing optical characterization area and the mechanics, electronics assembly area. This is what we'll see now. Right, Luis?
Yeah, right. ASE Optics facilities have different areas where we assembly and produce the optical and optomechanical systems, including the dark room where we did the optical characterization. Okay, we will show you all of them. Please, here's Thomas Siegel. He's our head of R&D, and he will show you all the labs.
Hello, Thomas.
Welcome to. Hello, Ivan. How are you doing?
Good. How are you? Yes, we hear you well.
Welcome to all to the laboratory part of ASE Optics. This is where we turn all of the design that you've seen upstairs into real products and into a reality. And also, as you'll see later, where we have the metrology, as was asked earlier, to enable the characterization and making sure that the instruments that we have assembled do meet all the requirements. So follow me in. So this is our main assembly area. Here we have assembly for all kinds of systems, be they with or without lasers. As you've seen the signs on the door, we do have a number of class 4 lasers. This is very dependent on the type of systems we're building. We have optoelectrical assembly here. You can see our engineers currently assembling the electronics of a couple of systems. And to the other side, you can see our clean area, which enables the assembly of optical systems as such. So this is the area where the lens by lens assembly can be performed. You can see the instruments which enable the non-contact measurements of each individual optics, which enable the tolerance analysis, which a lot of the time cannot be yielded just by passive alignment to be actively aligned lens by lens, and therefore to yield the global optical specs that are being sought for. In the rest of the area, we have the capacity to then align the optical systems. We can align the laser beams. We can make sure that all of the optical assemblies are as they should be in terms of optical characteristics. And also we do have a number of motion systems which we integrate into optical characterization equipments through the work of the team that you've seen upstairs. So here's some examples of some motion systems for optical characterization. These are probes and instrumentation that has been fully developed and integrated at ASE Optics for custom applications. And so here again, all of the work of the optical and mechanical engineers and software engineers come together to be tested and assembled here, following the procedures that were detailed by Jorge earlier on.
Excuse me for interrupting, Thomas. I hope I got your name right. What is that white assembly down on the floor?
So the white, yeah, it's a robot arm which is used for maneuvering optical probes, and this enables 6 degrees of freedom rotation of the optical probe that is ASE's design for the characterization of samples that are of importance to the client. So this is a catalog robot arm, which the control of which has been integrated into the full system, the control of which you can see at the back. And this enables the optical characterization through the motion of the probe with respect to its target.
So this is used for your testing of the characteristics. Okay.
Indeed, yeah. This one is part of the project itself. So yeah, we integrated the robot arm and its control in the full software, which is actually the example which Marina was showing you on his screen.
Okay, that's exciting.
Thank you.
You were talking about tolerances. Which applications you find to be the most demanding, and maybe what are the projects that you're proud of in terms of tolerances?
Yeah. So microscopy is definitely where optical tolerances are the most critical to be able to reach, whether it's MTFs or PSFs on the kind of submicron level, 1,000 lines per millimeters. The individual alignments of the elements within the microscope objectives do need to reach sub 20 microns, sometimes sub 10 micron alignments. And so we work quite a bit for cold atoms and large working distance, large NA objectives. And here the tolerances of each individual elements are critical to that kind of level. And even with that, extra compensators are to be used in the alignment of the systems, as you'll see in our laboratory, characterization laboratory next door.
Okay. Mark from LightPath, do you have a question?
Yes. Do you guys have ability to measure MTF, especially in the infrared, for the infrared systems?
So we have a wavefront sensor, which is limited to the silicon range. We have knife edge measurements, which we can use to measure PSF or line spread function more exactly, which we can then Fourier transform to the MTF. And we also have thermal targets, thermal targets, which we can use with the sensor, with the IR sensor, to be able to characterize the MTF, or minimum resolvable contrast, or minimum resolvable temperature difference, depending on which range you're talking about, of IR systems.
Okay. Do you typically normally measure perform any environmental tests or mechanical, like shock and vibe, or whatever temperature cycle? Whatever.
Yes. So we do validate our systems. We have partners with who we do that. We do not have the temperature testing rigs in-house. So that is something, especially for the defense sector, that is a sine qua non pass-fail test for the optics that have to be delivered. And so this is something that we account for in our design, but the actual testing we send out to be performed externally.
Okay, thank you.
You're welcome.
Okay, that's exciting. Thomas, shall we proceed?
Come again?
Should we proceed with the tour further?
Yeah, indeed. So I will now take you to our Optical Metrology Lab, where we do the characterization of the optics, which is just around the corner.
Okay. In the meantime, Thierry from Lambda X, maybe you can still ask a question.
Go ahead, Thierry.
It's coming.
Okay. Can you hear me?
Yes.
Yeah, I was wondering, since you mentioned a lot about optics, optomechanics, whether to do some electronics development.
So we don't do. So we do have some electronics development capacity. We don't produce PCBs, but we do integrate electronics, and we have partners with who the electronic design as such is performed, but our electronics department is mostly on the assembly, like some design, but on the light end. But mostly the electronics we integrate rather than design ourselves.
Thank you.
Cool. So here's our metrology lab. As you can see, it's free from external light, so that allows low light level systems as well as high power systems to be characterized. We have the ability to measure wavefront all over the silicon range. We do have capacity for the UV and the IR in terms of either USAF, direct imaging of USAF targets, in terms of point spread function or modulation transfer functions through knife edge measurements. So as you can see here, we have Mtf Bench based on wavefront sensor. We have a number of sources which enable us to go to do measurements from 2,600 nanometers all the way to about 380 nanometers. We have double pass systems for wavefront characterization, and also the engineering capacity to adapt to any other requirements that might be necessary for optical characterization. Okay. We also have capacity for characterizing night vision objectives and full systems. So this is something that we are quite active in, and we've developed our own optics and integrated intensifier tubes for night vision measurements.
Okay. Do you have experience handling confidential projects, maybe related with military?
Mm-hmm, indeed, and not only the defense sector, but also industrial and research. This is something that we do take very seriously, because many of our clients do trust us with their intellectual property, and so we always have all of the non-disclosure agreements in place early on in the projects to make sure that our clients know how and whatever they do give us as inputs that are necessary for the developments that we do carry out is kept 100% internally, and does not lead to any unwanted third parties. So this is very standard for us.
Okay. I'm sure several attendees in the room would be interesting actually to come with you with their projects now. Tracy, would you like to ask something?
Yes, thank you so much. So Thomas, I understand that this is the test and measurement area of the company, but I wanted to ask you something about the materials. So the materials that you use for the lenses, are there particular types that you tend to use? Are there any emerging material types that you're interested in?
So, I mean, in the visible, in the visible, we use kind of standard glasses. We have quite a lot of projects in the ultraviolet at the moment, and therefore doing chromatic compensation in the ultraviolet is definitely one of the challenges where material limitations are quite strong at the moment, because there's only so many materials that do have transparency, let's say to the 280, 300 nanometer range. And this limits the material selection, and therefore the designs that can be made for chromatic correction. And that's definitely a materials restriction. Going into the IR, we have played with a number of materials. I'm not an optical engineer myself, but I know there is a wide range that the optical engineers upstairs are using, and they are always on the lookout for anything new that might come out.
Okay. That's very good. Thank you so much.
Cool.
Yes.
Do you have any further questions?
I'm wondering, Thomas, do you have also experience installing these systems at the customer site and maintaining them after?
Indeed. So a lot of the systems, especially the more integrated systems that we build, do require installation on site and training of the future users. And so this is something that we can do. We can go with the equipment to the site, train the local engineers or staff members that are going to be using the equipment, and do a full transfer of how the operating of the developed instrument is carried out.
Okay. All right. All right. Thank you. Shall we proceed with the tour, or is that?
Mm-hmm. Yeah. So I'll take you back to the front entrance.
Okay. In the meantime, so yes, I remind you that in case you find this tour interesting and you would like to make a project with ASE Optics, don't hesitate to come to me or my colleagues at EPIC, and we put you in contact with with the client's support at ASE.
So we'll pass over the microphone to Andres, and he'll give his goodbyes.
Hello, everyone.
Yes, hello, Andres. Now we can hear you very well.
It's really loud. Anyway, so thanks for the visit. Well, real quick, if there's any last questions, I'm happy to answer now. And if not, we're really excited about your EPIC helping us, and like I said before, encouraging us to make this virtual tour. We're really glad everyone to join. So thank you for everyone that's watching. I appreciated your time. Thanks to all of the people for these great questions that have really challenged our engineering team. And I was really happy to see that we were able to respond many of the things. And also I want to thank my team or our team, because this is our company, and I want to give them a huge round of applause for all the great work that they do. So thanks everyone very much. And thank all of you. And I hope to see you here at ASE for real sometime. You're all invited. Thank you. Over to you, Ivan.
Thank you, Andres, and thank you everyone joining this tour. So this was virtual tour organized by EPIC, the European Consortium Photonic Industry Consortium, and today we visited ASE Optics Europe in Barcelona. Thank you and goodbye.
Thank you all so much. Thank you.
Bye-bye, guys.